Hello everybody. This video is about the Khan Academy assignment, find trig values using angle addition identities. Alright, so the angle addition identities are in your book on page 500. It's these right here. You can find them there. If you want to pause the video and copy those down, you need to have those probably on your unit circle sheet. Would be a good place to copy those down on the back or something. Anyway, before you do this assignment, you want to have access to these formulas right here. Okay, so I've copied them down right here. All right, so let's talk a minute, before I go on with the problem, let's talk a minute about what they are. It's a way of finding the sign of an angle that's not on this sheet by breaking it into pieces such that the two pieces are on the sheet, right? So for instance, let's say you wanted to figure out the sine of 75, the cosine of 75 degrees, let's say, okay? So the cosine of 75 degrees, when you look on here, back in the old days before we had a computer, 75 degrees is up here somewhere, so it's not on here, right? But I could change this to, I could say, all right, the cosine of 75 degrees is equal to the cosine of 45 degrees plus 30 degrees, right? Okay, now those two are on here. So 45 degrees and 30 degrees are on the unit circle, which most people that worked with trigonometry would have memorized. So now we can figure out what is the cosine of 75 degrees by referring to something that we know, right? In the formula for that, you would look up here at the cosine, and this is a sum of two angles, so we would use this whole formula right here, right? So I could say, okay, well, this is equal to, let me just maximize this out real quick. You can say, all right, the cosine of the sum of these two angles would be the cosine of the first times the cosine of the second. So the cosine of 45 times the cosine of 30 minus the sine of 45 times the sine of 30, like so. Now the cosine of 45, that's square root of 2 over 2, and the sine of 45 is also square root of 2 over 2, right? So this would be the square root of 2 over 2 times the cosine of 30. Cosine of 30 is square root of 3 over 2, so I change that to the square root of 3 over 2, minus the sine of 45 is also the square root of 2 over 2 times the sine of 30, which is a half, right? That's the sine of the y value. The sine of 30 is a half. And now it's just a matter of simplifying it. So when I multiply this, I get square root of 6 over 4 minus square root of 2 over 4. And that's the best answer that you're going to get, right? So that's in exact form. I guess one more step, we could say square root of 6 minus square root of 2 all over 4 would be the same thing. All right, so that's the idea. Once again, finding an angle, the cosine or the sine or the tangent of an angle that is not on the unit circle sheet by breaking it into pieces such that we do have two angles that are on the unit circle sheet. All right. So let me give you an illustration of how this works in Desmos real quick. So I've already got it in here actually. So you can see when I put the cosine of 75 degrees in here, it comes out to be 0.2588. When I break it into pieces using the same formula I just used, cosine of 45 times cosine of 30 minus sine of 45 times sine of 30, you see I get the same answer. Right? So that's the general idea. It's kind of a trick that mathematicians used to find the value of these trig functions for angles that were not memorized. Okay, so now let's look at your assignment here. So you've got this horrible expression here, and it says find the exact value of the expression without a calculator, and it says can't use this diagram, which is the unit circle sheet, which is you should have access to. So if you don't have yours, then you can use this. Remember, these exact values repeat on the other side of the circle. Just over here, you would have negative x values, right? Okay. So now what I'm going to do is I'm going to say which of these functions looks like this, right? Well, this is clearly this one. Notice it's got addition on top, subtraction on the bottom. So it is the tangent of the sum of those two functions. Now these pi over 12 is not on your unit circle sheet, is it? But basically what we're doing is we're taking the more complicated expression and we're going backwards to this expression. So that means I could just add pi over 12 and 5 pi over 3. So let me do that real quick. So I've got tangent of pi over 12 plus the tangent of 5 pi over 3 over 1 minus the tangent of pi over 12 times the tangent of 5 pi over 3. And I know by looking at, that formula that I just had, what I do with it right here, that is just the sum of those two angles. So this equals the tangent of pi over 12 plus 5 pi over 3. All right, now we just need to simplify this. So I'm going to turn this into 12s here, right? So a little work down here would be, what is pi over 12 plus 5 pi over 3? Well, let's multiply this by 4 and this by 4. Maybe that will help. All right, so this is going to be pi over 12 plus 20 pi over 12, which gives me 21 pi over 12, right? 21 pi over 12. And that will reduce because those are both divisible by, 3, right? So if I divide this by 3, I get 7 pi. If I divide this by 3, I get 4. So that's 7 pi over 4. Okay, so this up here then becomes tangent of 7 pi over 4. Well, where is 7 pi over 4? Well, if you look at your unit circle sheet, it's down here, right? So remember, this is 1 pi over 4. That's 2 pi over 4. That would be 3 pi over 4. Then another 45 would be 4 pi over 4. That's 5 pi over 4. 6 pi over 4. 7 pi over 4. And if you remember, tangent is just y over x. So it's this over this, right? It's negative square root of 2 over 2 divided by square root of 2 over 2. So this becomes negative square root of 2 over 2 over square root of 2 over 2. And that's just negative 1. So this whole thing boils down to negative 1. right? Let me go back over it. So I have this complicated expression, right, which matches this formula, which means I can work it backwards to this more simplified expression by just adding those two angles together. So I added those two angles together, gives me tangent of 7 pi over 4. I can look that up on the unit circle sheet, get the y value and the x value. Tangent is always y over x. Simplify it, and you get -1. All right, so hopefully that is right. It's on there. That's a good sign. Check. Okay, we got it. Let's try another one. Now here we're going a different route, right? We're given this simplified expression, and we've got to expand it. I'm going to write this down on my sheet real quick. So this is cosine of 17 pi over 12. All right. Cosine of 17 pi over 12. So now I'm going to break this up into two pieces. And I'm looking at this formula here, right? So I'm going to break 17 pi over 12 up into two pieces. And I want those two pieces, hopefully, to be on the unit circle sheet, right? So you got to play around with this a little bit. So 17 pi over 12, what can I break this into? To get an idea where 17 pi over 12 is, you know, pi over 12 is like right here. So that would be 1 pi over 12. That would be 2 pi over 12, right? I think that would be, it's about 15 degrees, 3 pi over 12. That would be 4 pi over 12. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it's right in here somewhere. Is 7, what was it again? I've already forgotten. 17 pi over 12. It's right about here. All right, so what could I do? I could probably break it up into 7 pi over 6, which is 14 pi over 12. So let me see. And I'm just guessing right now, right? Plus this other bit, which looks to me like about this one, you know, 4 pi over 12. So let me see what happens if I do that. So this is the same as 14 pi over 12, right? Just double the top and bottom, because since the problem is given to me in 12ths, then I would like to keep it in 12ths. So I try to figure out what two angles I'm going to use. And then I would have to add 3 pi over 12. All right, now what do these reduce to? Well, 14 pi over 12 reduces to what? 7 pi over 6. All right, I got that. That's right here. And this reduces to, what, pi over 4, right? And I got that. That's right here. All right, so I'm good. I figured it out. So this is going to be the cosine of 7 pi over 6 plus pi over 4. Okay. Now going to the formula for cosine, which is the sum of two angles. So that's this one. It's cosine twice of the two angles minus the sine of the two angles. All right. So let me write that out. I'm going to shrink this down so I have a little more room. Okay. So it's cosine of 7 pi over 6 times the cosine of pi over 4. And I believe that was minus, yeah, so when you're adding the sum of two angles, it is a difference in the sine of each angle. So sine of 7 pi over 6 times the sine of pi over 4. All right, this is just a little side thing here. All right, so let's figure out what is the cosine of 7 pi over 6. So looking at my unit circle sheet, the cosine of 7 pi over 6 is negative square root of 3 over 2. Okay, times cosine of pi over 4. Well, that's square root of 2 over 2. Minus the sine of 7 pi over 6 is negative 1/2 times the sine of pi over 4, which is also square root of 2 over 2. Okay, so what do we get? We get negative square root of 6 over 4 plus, right, because that's a double negative right there, square root of 2 over 4. And my guess is they'll switch these around, so it's probably written like square root of 2 minus square root of 6 over 4. They're going to, all right, hopefully I'm right. So let's take a look. Oh, they did not. No, let's see. They did turn it. There it is, right there. Okay. All right. Let's look at one more, and maybe I'll just set this one up. Okay. So again, this time they're giving you the complicated expression, and you want to turn it into something a little simpler. So let me write this down. The sine of 9 pi over 8 times the cosine of pi over 8 minus the cosine of 9 pi over 8 times the sine of pi over 8. All right. Okay. So out of the formulas, it looks like this one, right? Which is a difference in the two angles. A difference. So I would subtract those two. So 9 pi over 8 minus pi over 8 would be what? 8 pi over 8? So this should just be the sine of 8 pi over 8, or the sine of pi. That makes sense? Because if you notice, all you do is whatever those two angles are, you subtract them, right? And the biggest first, of course. So if I do 9 pi over 8 minus 1 pi over 8, that's 8 pi over 8, which is pi. So what is the sine of pi? The sine of pi is 0. So this whole thing is just 0. Now, if you put this into Desmos, I'm sure it would give you 0, but that's probably not the way you want to do this. You're just trying to get through the assignment. You get frustrated, I understand, but you want to try to play with these formulas a little bit to get used to them, so you know them somewhat and are familiar with them. All right, I'm going to stop there. That should be enough. Hopefully this will get you through the assignment. Find trig values using angle addition identities. Thanks so much for watching. Have a great day.